Alright, so let's look at this bouncing collision problem, and I actually want to leave you with the other two problems to begin with in this video. I'll work them again in another one. I'll work through this one a little bit quicker. Once again, I'm going to use the algebraic method combined with the guess method that we've always used in this class. So we have a ball, we have its mass, it's moving at another ball at 0.75 meters per second. We're given the second ball's mass and the fact that it's at rest. After the collision, the velocity of the first ball is 0.25 meters per second. What's the velocity of the second ball? Alright, so I have one ball moving in this direction, and it's going to hit an object at rest. After the collision, I know the velocity of the first ball. I want to know the velocity of the second ball, and let's see what our givens and unknowns are. This will be object number 1, object 2, 1 and 2. I know that the mass of our ball number 1 is 0.5 kilograms, and the mass of ball number 2 is 0.6 kilograms. Initially, the first ball is moving at 0.75 meters per second. So I'll say the initial velocity of ball number 1 is 0.75 meters per second. And I know the second ball is at rest. So that means the initial velocity of ball number 2 is 0. After the collision, velocity of the first ball, VF1, is 0.25 meters per second. VF because it's after the collision. And they want to know the velocity of the second ball, VF2. Okay. Masses don't change. I don't have to define masses on the after side. They don't change. The balls don't lose or gain any mass. Alright, so let's go through here knowing what we now know. Move this up a little bit, and we can solve this problem. Two objects to begin with, two objects to end up with. So algebraically that means row 1 initial plus row 2 initial equals row 1 final plus row 2 final. That F should probably be down here. And to flesh it out even further, again, I know I'm taking the long method, but I wanted to make sure that you know what's going on. Mass 1 times the initial velocity of object 1 plus mass 2 times VI2 equals mass 1 VF1. Mass times velocity, mass times velocity. I hope you see how we're doing that. It may sound like it's a long, arduous process to define all this, but if you organize your work and take the time to define your variables correctly, then you won't get them confused, because these type of problems are very, very easy to get these numbers confused. Alright, so now let's plug in, and because we defined everything correctly, I can simply look up here and see where mass 1 is. I know mass 1 is 0.5, initial velocity of 1 is 0.75, plus mass 2, which is 0.6, VI2 is 0. On the final side, we have the same mass, and the final velocity of the first ball is 0.25. Mass 2 is also the same, and I want to know what VF2 is. That's what I'm trying to solve for. Alright, so we can simplify this out a little bit. 0.5 times 0.75 gives me 0.375. 0.6 times 0 is 0, so that goes away. So 0.375 equals 0.5 times 0.25 gives me 0.125 on this side, plus 0.6 times VF2. And now it's simply algebra to solve it. Subtract 0.125 from both sides. And it gives you 0.25 over here equals 0.6 VF2. Divide both sides by 0.6, and you'll find that the final velocity of the second ball is 0.42 meters per second. And there's your example of a bouncing collision. All right. I'm going to give you a minute. Actually, I'll go ahead and work these problems on this video. I want to give you a minute to work on these middle two problems on your own. I want you to look at these two practice problems, the second and third one. I want you to work them on your own. I will go ahead and tell you the answers to them. You should get that the final velocity of the pair is 1.2 meters per second on this one, and I will work that out with you if you don't get it right. And you'll find for the third practice problem that the final velocity of the pair is negative 2.86 meters per second. Hint, hint, there's a negative here. Direction comes into play in this second problem. So pause the video and work those out on your own. Alright, here we go with the second practice problem. Toy engine with a mass of 1.5 kilograms and a speed of 2 collides with the second engine that has a mass of 1 and they lock together. What's the velocity of the pair after the collision? Drawing a picture is important. I have object number 1 that's moving in this direction, collides with a second engine that is at rest. Okay, so I'm going to write rest here. Right? After the collision, these two objects are now stuck together. Object 1 and 2 are stuck together, and they will likely move off in this direction. No, not likely, they will. They will definitely move off to the right. I want to know the velocity of the pair after the collision. Same thing, guess method. Givens and unknowns. They tell me that the mass of the first engine is 1.5 kilograms and the mass of the second engine is 1 kilogram. Mass 2, 1 kilogram. The first engine has a speed of 2 meters per second, so that's VI of the first engine. Initial speed of the first is 2 meters per second. And the second engine is at rest, so that'll be VI2 is 0. After the collision, they lock together. We want to know the velocity of the pair after the collision. So we don't know this total final velocity. Okay? And the mass is going to be the same. You can define it if you want to. The mass of this pair, the total mass, equals mass 1 plus mass 2. So that's 1.5 plus 1, which equals 2.5 kilograms. That's the total mass. Alright, so let's work this out. We have two objects to start out with. We have one object to end up with. So row 1 initial plus row 2 initial equals row total final. To flesh it out, this is mass 1 times the initial velocity of object 1 plus mass 2 VI2 equals the total momentum is equal to the mass total times the final velocity. We can say that's the final velocity of the total pair. Alright, let's put in what we know. Mass 1 is 1.5. Initial velocity of 1 is 2. Mass 2 is 1. VI2 is 0. Again, I'm just plugging in things here that I have in my givens and unknowns. By the way, this is the substitute and solve step. And I guess this will be the equation step where we went right there with that. Still using the guess method, just in case you didn't know that. 2.5 kilograms is the total mass. And I'm looking for the final velocity. Now we just have a little bit of algebra work to do. 1.5 times 2 gives me 3. This goes away to 0. So 3 equals 2.5 VF, and if I divide by 2.5 on both sides, I get a final velocity of 3 divided by 2.5, which is 1.2 meters per second. The pair moves off at a speed of 1.2 meters per second. Algebraic method, or you can do it this way in the table method like we did it first. That's the second problem. It's a locking collision. Alright, let's work on the third problem. Third practice problem should get a speed of negative 2.86. Well, here's how we came up with that. Fix my paper first. All right, so the third practice problem, we have two cars colliding. The first car, well, let's go ahead and draw the picture. Car number 1 is moving to the right and collides with a truck, object number 2. The truck is moving to the left, very, very important. So this object is actually moving the other direction. Very important because these are two opposite directions. Anytime you have two opposite directions going on, whether it's a collision with two objects or a collision with one object, one of those is going to be negative. After the collision, they lock together, and I want to know the speed and velocity of this pair stuck together. And I'm not exactly 100% sure what direction they're going to be moving. It depends on which of these two objects has greater momentum. All right, so before the collision, after the collision, let's define our givens and unknowns now and work the problem. I know that mass 1, the first car, has a mass of 450 kilograms. That's where I got that. I know that the second car, the truck, is 600 kilograms. 600 kilograms. These are fairly small vehicles, by the way. The velocity of object number 2 is number 1. This is the initial velocity of object number 1. Since object 1 is moving to the right, that's a positive velocity. So VI1 is positive 20 meters per second. VI2 is also 20 meters per second, but it's moving to the left at 20 meters per second. So I'll say that the initial velocity of object 2 is negative 20 meters per second. And you might be able to predict at this point that since this is the more massive object, that the whole system will end up moving in this direction. So we can probably get rid of this. We want to know at the end, what's the velocity of the pair after the collision? So we want to know VF right here. Our equation, two objects to start off with, one object to end up with. Rho 1 initial plus rho 2 initial equals rho total final. To flesh it out, this is mass 1 times the initial velocity of 1 plus mass 2 times VI2 equals total mass times the final velocity of the pair. Alright, now we can plug in what we know. We know mass 1 is 450. I know the initial velocity of 1 is positive 20. Mass 2, 600. And the initial velocity of 2 is negative 20. It's very important that it goes into the equation as a negative. If it doesn't, we won't get the right answer. The total mass, I might have done that over here. I should have done that. The total mass is these two added together. That's 450 plus 600, which gives us, I think, a total mass of, what was that? Problem number 3 was 2105, is that right? 1050. Sorry, wrong problem. 1,050 kilograms for the total mass there. So 1050 goes in here times VF, which is what we're solving for. Arithmetic work, 450 times 20 gives you 9,000 plus 600 times 20 gives you a negative 12,000. 600 times negative 20, that is, equals 1050 VF. 9,000 minus 12,000 gives us negative 3,000, and that equals 1050 VF. Divide both sides by 1050, and you'll find that the final velocity of this pair is negative, and it is negative 2.86 if you divide those out meters per second. Pretty bad collision. They're moving towards each other, and they end up moving to the right at 2.86 meters per second. That's more harmful for this person, obviously, because they change direction pretty drastically. It doesn't hurt. It's not great for either one of them, because they both face a pretty major impulse, pretty major change in momentum. This one has the greater change in momentum because it actually begins to go the opposite direction.